The following function computes the maximum value contained in an integer array P of size n. The code snippet has been given. We have a missing loop condition here. The missing loop condition is dash and 4 options have been given. So this is a C programming question. We have given us this function which computes the maximum value contained in an integer array P. Okay, and this is the implementation given in the function. They are asking us among these options when we apply the right missing condition, which is the right missing condition, which when we apply this function will return the maximum value contained in that integer array P. So let's take a look at this function and see what it does here. So we are passing the array P here and an int n, where n is the size of the array, and it said that n is greater than or equal to 1. So we don't need to worry about passing empty array or anything here. So at least size 1 array is passed here, and it is given a is 0, b is n minus 1. So here we are making a pointing to the start of the array and b is pointing to the end of the array. A is pointing to the first element in the array, b is pointing to the last element in the array. And there is some while condition. Inside that, if p of a is less than or equal to p of b, a is a plus 1, else b is b minus 1. And at the end we are returning p of a. So at the end we are returning p of a, meaning the maximum value should be p of a. So we need to find out the index a, which will give the maximum value in the array p. So let's assume p of a is somewhere here. Now in the loop, what it is doing, in every loop either this statement or this statement will run. If this statement is running, we will be increasing a's value by 1, meaning a moves to the right side. If this statement is the one that is run, which means b is b minus 1, meaning b we are reducing it by 1, or b is moving to the left side. So after, in every loop, a will either move to the right side or b will move to the left side. This will keep on happening until some point where a becomes the maximum value here. So clearly the ending part would be when a and b meets, right? If you take a look at the option, if a is not equal to n, then we can see, we can keep on reducing b going on, and b might move to the end of the, b might move even less than end of the array, right? B can move to the left side, reach the end, and then can go outside bound if we are using a condition like a not equal to n. If you are using condition like b not equal to 0, b will keep on reducing and reach till the end, but a can keep on increasing and go beyond the right side of the array as well, right? And if b is greater than a plus 1, this might work, this might also work. So we just need to look at option C and D here. So now let us see what's actually happening here as well. If p of a is less than or equal to p of b, if this element is less than or equal to this element, meaning this element is at least greater or equal to this element, so the maximum element might be this. It is definitely not this. That's what we know. If p of a is less than or equal to p of b, then we are increasing a by 1, meaning we are removing this element from our equation here. We are no longer considering this element. We are going here. Similarly, if p of a is greater than p of b, this element is greater than this element, right? So this element is definitely less than this, so we don't need to consider this anymore. So we are reducing it somewhere here. So finally we'll return p of a. That means a and b should be pointing to the same element at the end. At that point we can say for sure that that element is the maximum. So if you look at the option, that is clearly this one, b not equal to a. If you are using this condition, b greater than a plus 1, let us say a is 2, then and b is 4, b greater than a plus 1. So there is one mistake with this one, b greater than a plus 1, meaning initially itself this condition is satisfied. So we might not even look at many elements in the middle of the array into consideration for the while loop. So this also was wrong. This is the only answer, b not equal to a. Why that is the correct answer is, when this condition is satisfied, a and b will be pointing to the same element, and that will be the maximum. Until that, a and b will be pointing to the different elements, and we need to consider this part if p of a less than or equal to p of b. Till that happens, till a becomes equal to b. So the condition is b not equal to a.